I was muted. Hello. Hi. We're back. So, just real quick, I wanted to bring up the whole decoder stuff because that's what we did last episode. And I spent like 30 minutes at the end of the last episode, like 30 minutes afterwards, and I pretty much like figured it out. It's actually a lot simpler than I was making it. You know what? I should not have deleted the old setup because that's gone, but there is video evidence of it, right? But this is pretty much what I'm thinking. We're just going to get right into it, by the way. So I have the colors organized over here, and it's based on 0, 1, 2, 3, 4, 5, 6, 7, right? And I just wanted to show you guys like the whole logic behind it. It's still not 100% set up, but I think the logic is working. But the actual like interfacing with the pumps and whatnot, I still have to set that up. And I thought I'd just do that on camera. But the logic, I do want to show a little bit of how this is going to look like. And also another thing while I'm putting this stuff down, let me put it in a nicer spot. Let's do it right here. It is daylight savings time. And I never thought about it until now. Is that something that the world celebrates, or is it not celebrates? That's not really the right word to use, right? Is that just like a US thing? Or do other countries follow that? I have no idea. I never really thought about it until now because, you know, I'm here in a, I guess you can say, worldwide audience, which is pretty cool. I got plenty of people from several parts of the world that are watching. So I was kind of thinking about it. Yeah, people are going to see episodes come out a little later than usual because it's still the same time for me, but not necessarily for other people. I was just thinking about that literally in the shower like 5 minutes ago. Anyway, so this is the whole logic behind this little setup here. So by default, whenever this reaches 0, if I read the degasser here, that means no bits, machine overload, give 10,000 supercoolant, right? So that's kind of how this bus converter works. If there's nothing, like no signal going in there, which does correspond to the no bits machine overload thing, then the white signal is going to get lit. So that simulates this. So I would press it, right? So then that means this signal is being powered. But you see here that we're not getting a pulse. That is because just so that I don't, you know, nonstop run this when the machine is not working, I also have a signal to connect to the, what do you call it? The activity detector from the controller, so that it only works whenever it's actually running. So boom, there it is. So that's the signal. So this is only true if we get the no bits thing. It's made in the US, but some others observe but changes at different times. Okay. I just thought about it. I was curious. Yeah, it's going to cause some getting used to for everybody, I think. But we'll figure it out. It's only the first stream since it's happened. We'll figure it out though. And so probably the most complicated one is the bit 1, ozone sparging by inert gas. So this one, it's making it sound more complicated than it needs to be. It honestly isn't that bad. If this bit is on, you must insert an inert gas into the machine. That is just a fancy way of saying if this is an odd number. That's literally it. So that corresponds to 1, 3, 5, and 7. I won't go past 7 because when you have a bit like a 4-bit number, anything past 7 means that this one is active, right? This is 8. Like this is a 8 in binary representation. And bit 4 says if this bit is on, disregard all other bits and do not insert anything. So that's telling me I don't need to have any condition for anything above 7. So that's why the last one is 7. But anyways, what was that? Except Arizona, Hawaii, they are smart and stopped this nonsense already. I heard they were going to do something about removing it on the federal level. like sometime soon. I think it was this year. I heard that was going to happen, but I don't know anything after that. Drink some water. But anyways, so this one, if bit 1, and then it tells you interpret bits 2 to 3 as a 2-bit number. This is also making it more confusing than it needs to be. Really what it's saying when it says 0, 10,000 helium, that is the number 1. So if you have a signal of 1, the orange one, then enable the orange one. That's it. That's all it's trying to say. And then if this bit is on for neon, that is number 3. That's the blue one, right? And so on. So this one is what was that, krypton? Yeah, krypton is the lime. And then xenon is the gray. And you'll see here that some of them, like other things, are being interacted with. Like, for example, gray does interact with 3 of them. And I'll get into that. So bit 2, superconductive deionization. I can't say that. Deionization. If this bit is on, you must insert that one. So there's 4 different numbers where that is true. So that means this one, right? So there's the number 2. There's 3. There is, what is that, 6 and 7. So there's 4 numbers. And all I have to do is OR gate them, and that's what this is. So if the signal is 2, go ahead and activate magenta. If the signal is 3, you also do that one. But notice how it also does the neon and so on. The other one was like 5, I think. No. Whichever one is 5, this one. But it's one of them. Well, I guess it's all of these colors and gray as well. Yeah, 6 and 7. And then similarly, the bit 3 is the exact same thing. There's only 4 numbers where the bit 3 can be active, right? There is, with this number itself, which is 4. There's 5. There's 6. And there's 7. So I OR them all together right here. That's yellow, lime, pink, and gray. So if any of those are active, then we have an output here to push the molten neutronium. So that's really what this is. The white one corresponds to supercoolant. Orange corresponds to helium. Light blue corresponds to neon. Lime is krypton. Gray is xenon. Magenta is molten superconductor base, and yellow is which one? Molten neutronium. Yeah. So far it does work. I was able to like simplify it a whole bunch, and I was able to avoid that issue I was seeing last episode where it was like, oh, every time I turned one of them off, the orange one kept turning on for helium, and I was getting extra helium when I should not have. That has been fixed. And it was just because I had way too many loops that I did not need. It's actually way simpler than I was making it seem. And I'm real curious what the actual solution on the wiki is. I'll check it out later and see what they did differently. But for me, this is working pretty well. And I think this is just a lot of words. And if you really kind of understand binary representation, this seems a lot easier than it actually sounds. It looks complicated, yes, but I was playing around with it a little bit, and it was like, you know what, I can cram this into as small an area as possible, and this is what I got. And of course, I named it I'm Gassy, because that just makes sense. Stay hydrated. Okay, thank you, Allie. Good catch. I'm actually thirsty. Okay. A little bit of a rant to start off the episode, but I just wanted to explain my thought process behind all of this logic stuff. It was really fun, though, like setting this up. It was great. Okay, Allie, take care. And of course, the next step is to actually set this up. So this one no longer needs to exist. This is an old one. And this is the one that was not working, so I gotta get rid of it. So really, I'm pretty sure it works. I was, playing around with it here. how do I do this again? Yeah, like this. Like I'm playing around with it here, and it seems like it does work. Let me double check if they're all output as well. Yeah. And this one should be input. Yes. So this works if I just play around with it here. Like the correct signals will interact with each other. But of course, we don't actually know until we play test it, right? That's what we're going to do. As far as the fluid pushing goes, it's going to be very simple as well, I think. I think I'm just going to reset all of this. But I'm really glad that the devs did something for this. Like this kind of automation and thought process. I really like stuff like this. It's fun. Oh, it may not be fun for everybody, right? But for me, it is. It's literally what I do for work, kind of. I don't necessarily work with like designing circuits. I don't. I would like to, but that's not what I do. But what I do, especially at work, is debugging. And that's what I like to do. Sure that you're empty. Break the infinity pipes and then hue. Yeah, we have all of those fluids automated, so I don't really care about that. Okay, so how is this going to look? This is going to go directly into here, like that. I'm gassy. And then we need a signal here. I'll just leave that there. So we do need a signal here, and this one's going to be the frame box connected to the activity detector. And it should be the wireless one. And a receiver. A little bit of a rant, and it's not really a rant, but I think getting into this episode today was pretty fun, right? Immediately got into the confusing parts of it. Not confusing for me, but I'm pretty sure it's confusing for a lot of people. So what I will do, I think I'm going to do recipe progress. Yeah, we'll do recipe progress, and then frequency. I need a suitable frequency. I'll use a sniffer. Something about that word sniffer makes me laugh a lot. 3334 is a thing. I just put random numbers at this point. There's this device we use to, like, how do I say it? Well, let's go back a little bit. So, and I know I've talked about it before in another episode, but how cars, like their components, talk to each other, like all the various computers inside a car, they talk to each other through what's called CAN protocol, CAN, CAN protocol, right? And there's this device that we can plug into our test equipment that is able to detect like what communications we're sending to and from these units that we test, right? And guess what it's called? It's called a CAN sniffer. And every time I grab it, I just laugh to myself because it's just funny. It's just a little dongle, I guess. I don't know if that's the right word for it, but it's just a funny little thing. We call it the can sniffer. It's just a funny name. Okay, we have this guy. So this is that extra signal that we had up here. This one that will tell the white signal that there is a what do you call it? That the recipe is in progress. There we go. And then everything else, it's just as simple as adding connections to everything. So I'm going to pretty much just add all of the wires in order. So what colors do we need? I'm going to take a picture of this. Hang on. Windows, Shift, S. Open it, please. I need to see the picture on this on my left monitor. Yeah. And then take a drink because I'm thirsty. Okay. So the first one is white. So we would need a white cable actually. I need an insulated wire. Magenta as well. There it is. Gonna need a white dye. We only need one, so we're going to have one that corresponds to white. This is for supercoolant. Orange is for helium. I guess I should take a picture of the output, not the inputs, because the outputs are slightly different. You'll see here that they're not the same colors. They're kind of, I guess they are the same color. They're just ordered differently. So that's the cool thing about circuits like this or solutions. There's so many ways you can do this, honestly. And I'm curious to what the wiki solution is. I want to see what they did differently than what I did. I'm not saying mine is the good way or the preferred way. This is just my way. And I like to learn how to set up stuff like this on my own. It's a pretty fun challenge for me. But that is the disclaimer that I don't know necessarily if this is the right way to do it. But that's okay, right? It's really the main point of this is to like enjoy setting stuff up like this. So I'm looking at the picture on my left monitor: white, orange, light blue, lime, gray, magenta, yellow, and that's all we need. And another way to be sure that this is all we need, there's 1, 2, 3, 4, 5, 6, 7 colors. And then if I look up the tooltip for the degasser, I'm pointing at the screen like as if you can see what I'm doing, but there is 1, 2, 3, 4, 5, 6, 7 different fluids that this is asking for. You know, you got your helium, your neon, your krypton, your xenon, your superconductor base, your neutronium, and your supercoolant. There's 7 fluids. And then there's 7 colors here. So that works out. And then all we have to do is get more fluid tanks. Need more low voltage fluid tanks. And we have plenty of them, so might as well use them. Okay. And then each one is going to need a machine controller. Mm-hmm. And then we want to, how much fluids does it need? So the most fluid that any one of them needs is 10,000. So you really only need LV input hatches. Because remember, if you give it too much fluid, the entire recipe voids. So we're encouraged to not give it that much fluid. Like that. And then we need some fluid regulators. 7 of you. Like that. And then tiny infinity fluid pipes because I'm rich. That's really the only reason. I'm just flexing at this point. I mean, you might as well, right? Stuff's so expensive that it's okay to like, what's the word? Treat yourself every now and then. And plus, it makes sure like nothing gets stuck in the pipes, which can totally happen, I think. Go. 7 fluids, 7 things. Okay, so then we have to do configure each one. So if I look at the circuit here, there's a reason why there's a repeater and a pulse former. We found this out from the temperature the tier 5 water shenanigans, that for some reason, for whatever reason, whenever there's a repeater and a pulse former, you get 2 ticks at the output. So you can control these to account for that. So for super coolant, you want 10,000, right? So you just give this 5,000. Extreme. And then so on and so forth. You kind of missed out on my little not rant, but my whole explanation behind the updated tier 7 water shenanigan circuit. It ended up being a lot simpler than I was making it last episode. It's actually really easy. This is all it is. It looks complicated, but for me, it's like, it's very compact. I can probably simplify it. And honestly, I totally could. For example, like these wires can go just directly straight. I don't need this bundled cable. But I'm not going to touch it. It looks like it works. So, now just set up the rest of it, and then we'll play with it from there. But yeah, I was also saying that I'm kind of curious how the wiki solution is, and I'll look into that after this episode. Curious how they do it. From a high level glance, it looks pretty much like the wiki solution. And great minds think alike, right? That's funny though. Yeah, I'll take a look at it. This is completely from like how do you say it? Completely from the headspace that is like mine, I guess. I don't know the right words I'm looking for. Okay, so that's super coolant. And then next one is helium. So this one's helium. And you also set this to 5,000. But use machine processing state. Oh, that. But I'm going to go ahead and say that my solution is better because it's mine. That's it. 7,500 divided by 2. I'm gonna get my calculator out for this. I can do digital logic design, but I can't divide by 2. 3750. Okay. 3750. Who said calculators were not going to be useful when you grow up? Next one is Krypton, and that is 2,500. And then it is Xenon, that's 1,250, right? Sure. And then superconductor base is 1,440. That's a weird number. 1,440 divided by 2, 720. I'm also curious because you said that it's the wiki solution is not 100%, so that kind of frightens me or worries me. If mine's not 100% either, but that's okay because again, I like debugging, so it's okay. 2304, like that. What do you mean you don't like seeing red cables everywhere? But I do. Yes, Imgur. How do you pronounce that website? Continue without supporting us. Okay. What is going on with yours? Why do you have to? There's shulker boxes, or what's happening there? Okay. The wiki solution is a little. It's a little much. And you know what? If if that's the wiki solution, and I was able to cram mine in one block. And I think we're doing pretty good. Oh, you're saying tier 7 and tier 8. So you're telling me I'm gonna challenge myself to cram tier 8 in one block also. So far I've been able to do that because tier 5 water is also in one block. And now it is. Yeah, because before it wasn't, and now I was able to. All right. Challenges. Give me challenges like this. This is fun. I mean, we don't even know if it works yet, so I want to relax. Okay. So, wireless connector. Yeah, I need to connect it to A2. So, you also need a stocking input bus or hatch for the fluids. And I'm assuming because it's always going to be 100%, that I don't need to give this any of the tier 7 water as an input. It's just going to be tier 6 water, right? Yeah. So we'll put the stocking input hatch right there. And everything will connect like that. Okay. So there's how many channels I'm going to use here? 1, 2, 3, 4, 5, 6, 7, 8. 8 channels. Okay. A lot of channels. How many do you have? Do I just use that or do I start a new channel network? I think I'm going to start a new channel network down here and then just add on to it like that. Because I can cram more machines over here. But right there. You connect this. So I'm still far away from tier 8 water, right? How far away is that? I'll let you guys let me know. Man, but we've been doing Waterline for the past couple episodes. I want to move on. But this is all we're going to do in terms of Waterline for a while. It's getting this back to, or getting this to tier 7, and then honestly not too sure what we'll do next. But there we go. Now we have channels connected. Then you have all of you right there. You want to know something cursed? I've been ignoring progression and started bees. And progressed through Domcraft and unlocked the Cami tab. I don't know what that is. What's the Cami tab? Oh, is that for things like Ichor? Are you the one that told me, you mentioned it last episode, right? I don't think I responded to you. I'm sorry, but you had like 100 warp or something like that. Okay. Oh, jeez. Okay. It's a lot of warp. You got Wither spawning in your base yet? Super coolant. This one is helium. This one is neon. Neon, yeah. Krypton. I was literally a walking space distortion anomaly and everything around me turned to sand, water, and everything. Thaumcraft moment. It's not plasma, right? It's just gas. Okay. Xenon. Okay, so this is where I'm going to have like things like crafting cards, I think, is probably what I want to do, or hear me out. I talked about it last episode. I think we want to bring back level maintainers. but set them up to be a lot more nicer because our current level maintaining setup is kind of trash. It's right here in an old area of the base that is barely used. So I do want to go back to level maintainer, so I'm going to. Can't be that bad, right? And I'm thinking maybe we just put it not there because that's the subnet. We'll put it over here. I have a whole wall of them, sure. This might just be for like shenanigans, I think. Or I can keep it local. Nah. We'll have, yeah, we'll just put it over here for shenanigans. Let's do that. That mode. Yeah, exchanging. How wide are you? I can totally just copy this, I think. You have 32 level maintainers all in one place. It should last very long. Yeah, that's what I think that's what I'm gonna do. I'm just gonna have a dedicated area for level maintainers, and we'll do that. And I'm thinking about it too, that it's gonna condense a lot of our a lot of our machines. For example, once we get into Mark IV, Naquadol fuel, I don't want to set up like all of these machines, plus probably quadruple of them for that. We can just level maintain everything. Plus, another argument of mine is that we're getting pretty close to crafting input buffers, and that's a really good excuse to use level maintainers. Yeah, we'll stick to level maintaining. It also just encourages to build less machines, and you know how I am with that. So it's just going to be an area filled with level maintainers. Is this even? Is this odd or even? One off. Who cares? 15. It's odd. Go ahead and put you right there. Sure. Actually, that doesn't look very good because it's 32 of them is an even number. So put it at the corner. So we'll just have wireless connector there. Let's get another one right here. Dense cable. I think this is all you need, because if it's the same as ME drives, like this is how I connect them all. It's just 4 dense cables. So if it's the same here for the level maintainers, then that should be okay. I have something passively drinking UU matter in batches of 10,000. I can't figure out what. That's really funny though. So our entire plat line is level maintained still. And like after that, I went to passiving. And then I kind of just, you know what, let's go back to level maintaining today. So we are. Yo, thanks for the follow. Welcome. You're about to witness greatness of me setting up tier 7 Waterline purely out of just thinking about it on stream. So kind of surprised I was able to do it. It ended up being a little simpler than I thought. Just cram it all into this one block, and yeah, pretty fun stuff. Take a drink. Okay. So, 2 things that I want level maintained is neutronium. So this is also where my issue is. neutronium crafting is going to be a little funny. Actually, no, not really. Never mind. It's because we have something that's passively consuming neutronium liquid, but if I'm crafting it by the boatloads, then it doesn't matter. Before DTP, I expect to go through at least 10 million neutronium. I'm not going to do that. Okay, so how well has the level maintainer been updated? Because before, it just wouldn't work. Am I able to give it like fluid cells now? I just give it like that. Or do you have to actually give it the fluid? For example, this. No. It needs the fluid drops. Okay. Gimme. Like that. And then I want to have... I'm going to do 1 million because I don't know how fast I'm producing this stuff. Crafting batch size is... I don't know. 64? Does that work? No idea. $144 is an ingot. Okay. Currently exporting. Exporting where? What does it say? Oh no, it's working. It's doing its thing. That is crafting, but not. Okay, oh, there it is. Okay, so we just have too much of it. Hang on. So how does this batch size work? Does it mean it's trying to craft one at a time? Because, or how many recipes of at a time? I'm confused what this means. So so is this telling me that I'm trying to craft 64 drops of molten neutronium every time? But because our crafting recipe does 144. Oh, what the heck? I have to update that recipe. Hang on. Sir, I thought you were updated by now. Oh, it totally isn't. That's my bad. No, you're becoming a stack at this point. It makes requests of... Oh, okay, so I've been doing it all wrong. Okay. Okay, so I would have this like at... So by default, it does 92.16. And so I can ask for something like 92.160 so that it's 10 crafts. It tries to do 10 crafts at a time. Is that right? Until it reaches 1 million. Oh, rest in peace, our neutronium. Man, I had like 200,000 neutronium in here. 165, same thing. Oh, that is how it works. Oh, look at that. Okay. Okay, so what do you recommend? What superconductor base can I make reliably that isn't atrocious to acquire? How is UHV superconductor? I can make it in a DTPF. DTPF next. Say I won't. No. So I would need to craft the ingot. I don't think I want to do this because we cool this real slow. Okay, hear me out. For now, I'm not going to because we don't have a good way of making titanium. Because I think the only way you can get this is fusion, right? Somewhere? Yeah, this one. And we don't really have any good way of fusion, so I'm not gonna do this, I don't think, because it's a little tricky to make. Well, actually, no, 25. My question is if I can support 1440 liters. That's 10 ingots of superconductor base every, technically 120 seconds at most, but it's not always going to be that. But UV superconductor, how bad is this? I might just stick with UV. For now, at least. Yeah, because everything here is... Oh no, it's a quadria. Is it time for me to deal with my Nequadria situation? I'm going to do molten superconductor base. I think this is really the best way around this. Yeah. I'm going to change the recipe also. That's why it becomes more important to run huge water batches to save in input costs. Yeah, okay, okay. I'm going to use superconductor base UHV. I'm going to have it stocked also to 1 million. And then also 92160. We'll see how far I get. I'll let it build up for a little bit. 1,000 UHV circuits. I crafted a whole bunch of them off camera. Yeah, this is what I'm kind of worried about. It's how slow we craft molten titanium. So I'm not too sure if I want to do this. Yeah. We won't do this until we get our fusion dealt with, because I forgot it also needs uranium. Yeah, we can't do that. Never mind. I'll come back to that, because one of the goals, or one of the immediate like adventures we're gonna go on soon, is a lot of fusion, because it's we desperately need more fusion. So I'm gonna give it the UV one for now, because that one I think we can make a lot more reliably. For now. Then I want to smelt this. Waterline is basically a check of the depth of your power storage and your ability to provide it with the most power. So it boils down to power equals water. Gotcha. Yeah, that does make sense, actually. Mr. Extreme, also known as Extreme Knowledge Check. Thank you. No, by all means, it's good stuff. 92160. Alright, try that. Those fusion reactors made like a farting noise. Did you hear that? Where am I? Over here. Okay. So you are going to be superconductor base UV. No. Yes. Never mind. And this one is neutronium. Like that. Get out of here. I mean, I might as well give everything acceleration cards, right? Or just a couple hyper cards. I don't think you need acceleration cards, honestly, because it's only every 120 seconds, right? So you can totally fill up with that much in 120 seconds. I'm not gonna worry about it. So here's the issue. It's not able to craft it because it keeps running out of... like, we can craft one batch, but it wants to craft 10 because that's how we have it set. So if I try to do 92160, it's the lack of Nequadria again. So I think it's time for us to finally deal with our Nequadria situation. And the answer to that is just take it off of here. Stop consuming my Nequadria. Actually, think it's these recipes that we want to stop doing because we still need the Nequadria ingot for other shenanigans, and those don't get consumed too often. Yeah, they don't. It's this stuff here. So for now, I'm just going to break those so that they actually then they give me my heat proof. And this also does convince me to just maybe just level emit the like the emulsion stuff. I don't know. We'll think about it. But that's where all of our Nequadria is going. If I look up extremely unstable, we have 16 million of this. And I'm not too worried about the emulsion because you really only use this stuff for the gas, right? Yeah, for the Naquadol fuel. But we have so much of it that I don't. Yeah, we have time, so I'm not worried about this. And I honestly think we have enough time until Mark IV fusion or Mark IV fuel, which is when I'll fix all of the crafting thing. So we're okay. Watch my base shut down though next episode. I think we're okay. How much Mark IV fuel or Mark III fuel do I have anyways? We got 3.4 million. How much is that? I think that's a ton, right? So I'm not going to worry about it for a little bit. You can go for NAC 4 now. Do it. So I technically can. The two things I would need is how the heck do you pronounce that? Praseodymium and the tier 2 coils. Press is free. How do I get the coils though? Oh, advanced field restriction coil. I'm assuming it's those. These don't look too bad actually. Yeah. Yeah, it doesn't look too bad. I like how it's all this super expensive stuff and then lubricant. S tier good. Yeah. How much? Oh, it goes to tier 4. How about tier 3? Ugh. Ew. Now I'm just curious. I want to see what the tier 5 is or the highest tier 4. And that whenever you see that word temporal, that's not good. These things aren't even holding still. Jeez. Is this even a thing you can craft? Yes, you can. Okay. It's not bad. It's just space time. It's such a funny statement. I'm gonna hold off on it for now. It's not the priority. We have a lot of fuel, but I think right now I just want to get the water built up. So, with that said, what is a good parallel to do for this thing? Oh, I think we can even get this working like right away. Another thing I can do to like really make sure that this isn't going to fall apart is to like the safe way to do all of this is to actually add like fluid detector covers, wireless ones, and then just set up like a signal to like tell the machine, hey, don't do anything. That would be the smart thing to do, but I'm not a smart person. So I think I want to run it for 1 cycle. I'm curious to see what it does. And we're going to give this like, how much power does this use, first of all? That's, is it 64? Is that a lot of power? Say it with me. Residual decontaminant degasser purification unit. Oh, yeah. Got a minute. I think it's ready to start. Actually, you know what? Before I do that, I didn't even troubleshoot the thing. Let's make sure it actually works. Okay, so here is the number here. Let me set up my redstone lamps so I can understand this. Is your water line single threaded, running a single water at a time? No, it does. It does whatever it can. It is level emitted. So if it detects that there's more than, well, for grade 1, it's 1 billion. Grade 2 is 2 billion, I think, but all the other ones are at 10 million. So if any of them detect it, then it runs that specific one. But if they're all less than 10 million, then they're all going to run. So no, it's multi, I guess. Let's just see if this actually works. I'm going to get my redstone lamps for debugging. So if I put 1, 2, 3, 4, oops. So most significant bit is the left one, least significant is the right one. So this corresponds to 0 and 1 and so on. So this is a signal I want to give it. I just want to see if it actually works. Make sure that this is off though. It's off, okay. So circuit 1, right? That is a 1. That corresponds to this. And based on this, that means I should only see helium, and that's it. And we will check all of this stuff. There's 10,000 helium. Looks like it's good. And then, number 2, this is 2, which should correspond to only superconductor base. Oh yeah, 1440? 1440. Okay, it's looking good, it's looking good. Circuit 3, or signal 3. So this one means superconductor base and inert gas, but it says to use bits 2 and 3 as a 2-bit number. So this should correspond to neon, I think. All right, because this 2-bit number here is 1. So that's neon. So I should see only neon and superconductor base. Oh, I messed up already. Oh, I didn't change it. My bad. I thought I messed it up. No. It just didn't change. 7,500, right? Yeah. Okay. No? Hello. If this bit is on, you must insert 1440 superconductor base. So it didn't seem to do this one either. Uh-oh. Do I have that right? So number 3 is 0, 1, 0, 1, 2, 3. Yeah, it should have output that. So I'm not sure why it did not. Uh-oh. Why'd you break? Unless these only transfers one signal at a time, it shouldn't, right? It should be multiple signals. Let me see here. Take this out. We'll try again. So number 2 should just be superconductor. So it does work with, like, right there, but why didn't it work without it? So at 3, it's not. So it's only doing 1 at a time, I think. Which is interesting because based on this, it's doing multiple at a time. So that corresponds to blue. right? And it does light up the magenta color, which is superconductor base. Okay, so let me see if that shows up in other situations. So maybe it's just something I missed, or another consideration I didn't think about when it comes to this stuff. Because I'm imagining that only one signal is turning on from the input, and then the output can be multiple. Okay, so right now it's at 3. If I hit 4, this should just be multineutronium. And there it is. Okay. 4608, right? Yeah. So it seems like it works fine if it's just one fluid at a time, but once it gets to 2 of them, for example, this one. So this one is 5, and 5 corresponds to neutronium and krypton. There's krypton and no neutronium. Okay. So it's only doing one at a time. Why? So maybe I don't understand how these lights or these wires work. Here, hang on. Let me unplug all of this, and I think it's easier to just use redstone lamps for all of this stuff so I can see everything. So I'm just going to connect everything how it was before. Like that. How do I have it set up? Orange. Light blue. Light blue, lime, gray, magenta, yellow. So I think the logic is there, but I think we're just missing out on how these things behave with each other. I think you need an extra wire, right? No, not that one. I'm looking for this one. Like that. Okay, so it does turn on. So first one we saw that was not quite working was signal 3, right? The signal 3 is 0, 1, 2, 3. Yeah, we should be seeing blue and magenta for signal 3. Oh, you saw that, right? Well, actually, no, that's fine. So it's only one at a time. Why? When this clearly says it's doing 2 at a time. Do you think it has something to do with like tick behavior, that it technically can't do both of them at the same time because of tick things or whatever, and it prioritizes the first signal it sees? So maybe I have to have them all on different timers, like different delays maybe. That is not difficult to do, so I'm going to try that. Because of that pulse, we should expect only one signal anyways, so it's okay. I have 120 seconds to give that signal, so I can give any amount of time here. I can always just do this. 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So now they're all on different timers. So I can always do this, right? Yeah, it's a little slow, but maybe that's what it's looking for. Yeah, we'll try it. We'll try it. If you don't know what's drinking this UU matter, just go nuclear and just shut off like UU matter production, and then just see wait to your. I don't know. I'm just kidding. Okay, I'm curious about this. I'm going to break this. Actually, you are 2, and then I'm gonna break it. It should be identical, other than the timer. Goodbye, I'm gassy. You're gonna get replaced with another one. Okay, how about now? How about now? Oops. Put it down. Okay, so does this work now if I set it to 3? It didn't do anything. What? Okay, that one turned on. That turned on. I'm so confused. Why does it work in the schematic table but not in real life? Oh, this is just like in like how circuit design works in real life. Jeez, I would imagine. I mean, on paper it works, but why doesn't it work like here? So circuit 2, or not, I keep saying circuit 2, but 2 corresponds to that one, right? Which is okay. That's okay. 3 should be you and you, but you don't turn on. Maybe if I watch it enough, it'll work. No, it's not gonna work. It's my problem with wiki solution. Theoretically, it works. Practically, it imitates real life. Yeah, this is weird though. It works well on the board, but not in person, which is really strange to me. So, what if I'm gonna try something dumb? I'm just gonna keep adding stuff to it until it works. Let's try adding a repeater to this. Well, I don't think that's gonna work actually. Can I not control Z? Nope. Oh, you're gonna make me add all those wires again, right? I think what's happening is that this bundled cable is lying to me and it doesn't actually transport more than one signal. Or there's some kind of like delay or something. What if I connect the bundled cable here? It literally doesn't do anything different, but what if? Oh no, I'm getting a little not desperate, but I just want to figure this out. Let's try that. Trash you. Get you. Okay. There we go. I'm gassy. Okay. Okay, that worked. You guys saw that, right? I'm the smartest person alive. Did it work? It worked. When I put it down, it worked. It did something. Okay, so I don't think it's a delay thing. So what I'm going to do, just to remove that variable again, I'm going to put the repeaters back in order so I can see everything live. It's a lot easier to deal with it like that. So I'm just going to remove the repeaters and put fresh ones down like that. Okay, and try this again. That's weird. It worked on that. Oh, and it might be like a block update thing. I've seen that happen with some of the ProjectRed things before, that it just doesn't really work well until you update the block. So maybe I need to have some way to do that. I don't know how to do that though. For example, it's on 3, right? So if I put this down, they both work. 2 works fine. 3 should be both, but it does not. But if I update the wire, no, I don't do anything. Oh, that's because it didn't update. Hang on. Let me. Should be able to just update this one though. It works. Okay, so I need to find where it's getting, where I can update. It's this wire. You're the culprit. Make this vanilla redstone. Watch this. Watch this. Here we go. Here we go. I make this. Oh, it's the vanilla redstone. No, I was close to it though. I'm so close to it. It has something to do with updating blocks. So I need a way to, like, I don't know. This is tricky. It's ProjectRed being dumb. I've seen this happen before, especially with comparators. They don't really work well until you update the block that they're on. I faced this a lot in nuclear craft. By the way, yes, the distance at what you put between the degasser hatch and the bus converter matters 100%. I mean, I had it 1 block extra and it was shifted to lower power. It should be fine right here because it's working correctly. So circuit 1 does work. 2 works fine. So I need something that changes redstone and also updates itself when it changes redstone, because I don't know if redstone dust updates itself. It has something to do with block updates. I don't know how to prove that though, and I don't know how to deal with it. So there's got to be something that I can use that updates itself. Comparator? Maybe a comparator. Try a comparator. We're getting into the realm of like Psycraft, sort of like debugging. Getting into the nitty gritty of Minecraft and how cringe its code is. So this is what I'm gonna do. I'm gonna break this. I'm gonna put a. Hang on. How am I going to get? I'm gonna have to move the hatch, right? I would have to move the hatch 1 down. Okay. As far as I'm aware, whenever you have a comparator like this, that is going to match, right? So it just moves it there. So I hope that the comparator updates. If it does, then I think that solves our problem. We're gonna use vanilla redstone because I just will. Okay. 2. No. It's not the thing either. Yeah, it needs to update. I need something to update. It's weird. Red crystal is another option. I'm getting into all the weird stuff. Alright, we're gonna figure this out. No. The only other thing I can think about is having some weird like piston thing that moves a block. I'm curious. Let's just try this. It needs to be a sticky piston, right? Oh, we're going into vanilla redstone over here. That's okay though. This needs to happen. At this point, I'm not gonna use a potentiometer. I just need to figure this out. Needs to be like a pulse here. I'm trying to think here. Because you can move blocks through this, like power. Right? Or do I have to like actually give it power? Okay, it does work. That's gonna break it, so don't do that. I didn't know I can do that. I just assumed that it would work and it worked. Oh, that's funny. Anyone know how to do vanilla redstone? Because I sure don't. I have a lever on me. Can't put a lever on it? How dare you? Okay. So if I were to give this like a... So my concern with this, actually, I don't think I can do this now that I think about it. Because whenever I do this, this one is going to activate. Which means it's going to put super coolant and it's going to break our setup. So I can't do that. I think our answer has to lie somewhere that doesn't break connection. It has to keep the connection consistent. I can't do the break signal method. I probably could, but it is a little weird. No, I could actually. Trying to think here. And we may have to play around with it a little bit. This is going to be pretty interesting. Is there any other thing we can do that powers redstone that also updates itself? Servers, right? Oh, block update detector? Maybe. Well, maybe this would like prove like what I'm thinking about. Actually, I'm just gonna build it, see what it does. Oops. Go right there. The more I'm kind of interested in Gardener Grind, it forces you to use the absolute worst passive progression. That's cool though. I can craft already. Right, sure. So this is what I'm curious about. If it... I don't know how this works. Okay, but what signal do you give when you update? Is it based on redstone? You just give a straight 15. Okay, so I can't really do that. But the thing I'm looking for is... Oh, it tells me here. An adjacent block is updated. It will send out a 1-tick redstone pulse and then go inactive for 3 ticks to allow the redstone to... Let's try an observer. I don't really know what an observer does. I'm gonna be honest. I'm gonna try it anyways. Don't go blowing up on me right now. I don't know what this does. So this is the one that detects a block, right? And then it gives a signal. But is it able to control, or is it just like... It's just a consistent 15, so I can't do that either. I don't know. It's such a weird thing to deal with. Let me see. I'm going to have to Google it. Let me see if there's other people that has seen this issue before. ProjectRed. Bundled cable only one signal. Having an issue with bundled cables. This is a little confusing. ProjectRed tells me that, or the GTNH wiki. It does talk a little bit about ProjectRed. I know how that works. I'm just looking for the bus or the cable here. When it's physically impossible to do that. One enables the forward direction and the other enables the reverse. I don't even know what that means. Color is chosen at random and changes every 2 ticks. What if I just add like more signals? Is there such a thing as a converter that converts that to that? And then how do I explain it? I don't think that is a good idea though. No, because there's multiple signals going through this. Bundled cable. Curious here. Bundled plate. Bus transceiver, bus randomizer, bus converter. Bus input panel? No. Bus transceiver. I want to make this. I don't know what it does, but I'm going to make it. I'm telling you, if we can figure it out, I think the community can make use of this. Or maybe they already figured it out in the community. Who knows? I'm pretty sure people are like very smart there. I just assume they're very smart. So I was thinking of having something on the inside that actually lets me move the signal. I was thinking something like this. No. It has to be a little bit different. First of all, I gotta move you. So this one is going to be there, and then transceiver, bus converter like that. And then frame box. I'm just gonna not put this yet. So if I were to give this the potentiometer thing, I don't think it works. I think I have to... How does this work? Bus transceiver controls the flow of redstone signal with powered latches on either side. One enables the forward direction and the other enables the reverse direction. What does that even mean? Don't do that. How do I know which direction is which? I'm gonna try that. Oh, that doesn't seem to work either. All right, you're going back in storage. We're gonna get to the bottom of this, I promise. What if I add another cable right there? Another bundled cable. Oh, did something. Why does it work when it goes backwards? Okay, it works when it goes backwards, but not forward. What the heck? So it didn't even work at all. Oh, it's just multiple signals. That's why they're not connected to the power. It works backwards, but honestly, I'm starting to think that maybe it'll work with the input with the hatch. It might even be a potentiometer thing. It could be, right? So let me try that trial again. If I don't need to have an extra cable, if it works backwards. Because it might be a potentiometer thing. Because it kind of goes up and it goes down. But the hatch probably like just sends a signal each time. Emits a strong redstone signal on the bottom side. I gotta think about this. This is weird, and there might be other considerations now that I think about it. Hatch is the same as a potentiometer. Okay, so this is what I just thought about this. I think we need a pulse as well. Because how... So is it ever going to give the same signal, in other words? So like, let's say I guess I'll plug it in first just to see what it does. Try to explain what I'm thinking about. Maybe this is one thing I didn't consider. So let's say the first signal is 3, right? First of all, if I go backwards, does it work? It works when I go backwards. So let's say the signal is 3, right? On the next cycle, is it going to change? What happens if it also gets a bit 3? If the signal doesn't change? My stuff has no idea what to do if that's the case. Unless I add the IC blueprint. The activity detector. I'm going to have to do this for all of them, I think. I didn't think about that until now. So there's a chance, I'm assuming there's going to be a chance that the signal does not change. And if that's the case, then we have to account for that. And I think the activity detector is the answer to that. We should just leave it on recipe progress. I think that's the answer. So how am I going to do this? That's kind of that's a little weird. Oh, it's going to be a mess. How am I going to do that? I can't even fit enough signals into here. I'm going to have to like expand this, I think. But maybe that's the answer, honestly. Now that I think about it. I'm going to try it for because right now we're just debugging 3, right? I just want them both to work. So we're just going to debug that one for now. Is these signals, and that's it. I'm also going to get rid of this one for now. So this is what I want to see. I think just to make things easier, I think I do want to have a bundled cable here. No, one lower. put it right over, put it here. And then we would have, remove the simple IO. And give this a color of black. We'll just say black for now. And then we would have AND gates. There. So I really am only looking for these. Like that. And then black cable. That looks atrocious, but you know what? It's fine. And I don't really care about those either. This is just debugging. Magenta goes like that, and then light blue like that. Okay, so if I hit 0, 1, 2, 3, I should see only these two turn on, but I need to have this enabled like that. Okay, you see a bunch of them turn on, but that's fine because I'm only looking at blue and purple. Actually, no, that's not going to be good either. Disconnect those for now. Yeah, okay. Let's try this. I completely broke the circuit, but that's fine. I'm at this point, I'm just debugging. Might be able to fix it like this. Feel like a mad scientist. Okay, so right now, so this mimics the case where the signal did not change from the last cycle. It's still 3. But we're waiting for the activity detector to report a 1 or like anything else really. Because that tells that the recipe started like, I think it was 10 seconds is what I counted, something like that. There it is. That's the answer. It's the activity detector. Okay. Sweet. So how the heck am I going to I have to add that signal to like all of the That's going to be a little bit of a mess, but it is a mess that has to happen regardless. So let us do this mess. Yeah. Okay, we're gonna have to fix this. And I'm gonna fix it like this. Watch this, watch this, watch this. Oh, it's gonna be a big mess. I didn't know I was gonna do even more circuit design, but I'm gonna have to. It's gonna have to happen. So I'm gonna have to separate each one of these. I'm going to, yeah, I'm gonna have to get rid of everything. And then let me take a screenshot of this so I don't lose track of it. It's gonna work. I hope. I find myself saying that so often at work. But I still remain like hopeful that all these issues that I see at work, I'm gonna fix them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We have enough space. It was also like an extra challenge that I gave myself to cram it in the smallest space possible, which is this one, is 16 by 16. Gray, magenta, yellow, output, output, and output. Okay, I think that's it. So every one of them is going to have the same thing, a pulse former, because you need the pulse former. No way around it. You need the pulse former and the repeater. Then I will connect them to their respective colors. I think I need to learn to trust Occam's razor way more often. Which one's that one? Is that's usually the simplest solution? Is that what it is? So what's your answer? What happened? What's eating all of your UU matter? Each one is going to have a... Oh, we have just enough space for this, actually. This is a really good. but each one needs an AND gate. What's eating UU matter? Is it your scrap UU amplifier? 3. Elemental duplicator. What are you duplicating? Is it prosody, whatever? Praseodymium, whatever it's called. It looks red. Well, duh, because I had no UU matter. Controller says off, but I think it's disabled. I don't get it. Do that. This is input mode. So this one over here is going to correspond to the what do you call it? The activity detector. That's the black cable. Is it just not enough power? It was duplicating brass dust. Okay. Turn this off. Thank you. Orange. Light blue is right there. Lime. Gray. Whatever that color is, and magenta. Okay, this is looking like atrocious, but and this is also does not need to be there. There it is. You know what? You go straight ahead too. Just because I can make you go straight like that. Okay. This looks atrocious, but this now has the activity detector accounted for every single one of the output signals. So signal 1 means give me supercoolant, and then it waits for the activity detector to enable. Boom, and there it is. That's just one. Okay. Now the one we're having trouble with is this one, which corresponds to output blue and output magenta. But we wait for the activity detector again, and there it is. I think that's what we're looking for. Let's try it now. It's a good thing I thought about the activity detector. The only thing is that it's going to be on the other side from now on, because I don't have space otherwise in the schematic. There you go. I can just give it a lever here. And just like that. Okay. So for example, this one is circuit 3. So right now, this is mimicking whenever the controller restarted. And then it takes like 8 seconds or something like that for the activity detector to enable. Boom. And that's what the two signals are. There we go. Okay. I think this is it. It's a big I think, but I'm just curious. So I will actually play around with it. Connect everything back to where it was. Okay, and then I'm going to mimic the activity detector. Need some strips here. That, and then like that, just to block it a little bit. You don't go connecting where it don't want you to. Okay, so then we can go back to here. And I'm going to have to restart all of them just to make sure that it is working how I intended to. Let me take a drink. Okay, do a couple squats for good luck. Okay, so the first one I want to do is circuit 0. I keep saying circuit. No, it's signal 0. That corresponds. Well, first of all, let's maybe check if there's anything in here. There's not supposed to be anything in here because the activity detector is quote unquote off. So at 0, that should be supercoolant. So activity detector turns on for a couple seconds, and there's a supercoolant. Nothing else. All right. Okay. Activity detector turns off, and let's say it goes to signal 2 or signal 1. Set this. So this corresponds to just helium. Activity detector turns on. There's a helium. Activity detector turns off. Machine goes to 2. That's the next cycle. Set this. So circuit 2, I keep saying circuit 2 corresponds to just superconductor base. There it is. Nothing else. Looking good. Here's the moment of truth, the one that was giving me all of the issues. Number 3 should be both neon and superconductor base. Activity detector turns on. Nervous. Neon. Oh, we got it. There it is. And now here's the true test. 3 fluids, because there's also cases where we have to put 3 different fluids. I'm gonna trust that works. Actually, no, we have up to signal 7. Everything past that doesn't really do anything. I messed it up already. It wasn't supposed to do that, sorry. Let me restart this. Yeah, this is molten neutronium, which is number 4. Actually, that worked out correct. That's fine. But you have to turn off the activity detector, which is this signal right here. So 5. 5 corresponds to 101. That is krypton and neutronium. It's krypton. And there's the neutronium. Okay, it just lagged a little bit. I got scared. Turn that off. 6 is 0, 1, 1, 0. 0, 1, 1, 0. So that is superconductor and neutronium. That one. Okay, it works. Oh, it's just lagging. The moment of truth. 3 fluids. This one, number 7, is xenon, superconductor, and neutronium. Oh, yo. Oh, man, I'm the smartest man ever. Oh, man, this is so cool. I'm loving this. I think we're good. Man, we're learning so much about redstone and like how buggy it is. And it's something to do with this one is actually what's causing that weird update thing that I was talking about. I don't know. I'm gonna trust that it works. So far, every single signal worked. I guess one thing we can triple check. So anything past 7. So for example, 8. Because anything past 7 is going to have the 4th bit enabled. Then just don't do anything. And I have that accounted for in the signal or in the IC. It's accounted because there's like literally nothing connecting to it. And then if I enable this, I should not see anything. Oh man, he's so smart. Electrical and computer engineering was my major. I didn't even focus on the like digital logic though. My focus was analog circuits and electromagnetism. I say that, but I don't understand it, so don't ask me questions about it. And it was like 5 years ago since I graduated, but it's because, like, even though I studied this stuff, I think my expertise or what I'm good at is debugging. I fix things. So if you give me a problem, I'm gonna fix it, and like I don't give up. Okay, I think it's working though. It's atrocious. It's a mess, but it works, and that's all I care about. So, in order to actually oh, don't do that. You broke everything. In order to get it working with the actual thing, I need the frame box down. Right there. And then you have this man over here. 3334. So you're pretty familiar with building consistent signals and protocols or stuff over something like that. So it's like I talked about, really the only like communication thing I'm familiar with, and I'm only just starting it, is because I work in the automotive industry. So the protocol that uses CAN, or CAN, I talked about it earlier. I'm only just getting starting, like just starting to understand it, but that's really the only like communication thing that I used before. It's interesting stuff. But I guess you can also say it has to do with integrity, yeah. So, you know, if there's one bit that's off and not working correctly, your whole thing's gonna break. Because these signals do, like, they determine things like RPM of a pump. You know, what kind of signals they output, what voltage you're measuring, things like that. It's a bunch of fun stuff. I think it's 3334. Okay. But I like to debug. Potentiometer does not need to be there. I just broke everything. I think we're good. I'm gonna, you know what? I'm gonna leave this as a kind of like a diamond chest because we're rich. I'm gonna leave this as a trophy to our efforts. There it is. It wasn't just me, it was also you guys. I had a lot of help from the audience. Thank you. Some good ideas. I mean, I'm saying it as if it completely works, and I don't know. Ultraviolet. The fun part is, if you want to make your system reliable, it literally needs a math proof and it has to be right. Yeah, I know. I don't know if it works even. Okay, but I'm assuming it will. And it's like I said, the smart thing, a smart person would actually have fluid detectors on every single one of these that will tell the whole system, don't do anything if you're missing a fluid. But I'm not smart, so I'm just going to try it. I think we're good. Try it. Try it. When's the next cycle? Oh, it just started 10 seconds ago. Oh, no. Turn it off. There's no output. Duh. Hang on. How do I think I need to give this a dense cable? Colored black. I don't want to do that. It's because I'm pretty sure that if there's only black cables, like the small cables, then the channels also, I guess what I'm trying to say is it's better safe than sorry. Just give this a dense cable. Okay, take care. Thank you. And if you guys can see the look on my face right now, I'm like squinting at this computer so hard, trying to save face. Is that the word? Trying to make it seem like I know what I'm doing, but I really don't. Okay. And then you need an output. Output hatch. Yes. Thank you. You go right here. This is by far the most complicated thing I've done in any mod pack. By far. And I'm loving every second of it. The next complicated one is solving the endgame puzzle of Divine Journey 2, but I'm not going to spoil it. You know what? You can put that here as well. Actually, no, the creative IC chip is that goes in storage because I might need it for other things. Okay. You have output, you have input, you have a whole bunch of other inputs that are controlled. Let me double check there's nothing in there because it's going to void if there's anything in there. Get out my scanner. Take a drink. I have to say that every time because I feel like there's a dead air whenever I don't say it. Just me, I'm just making sure. Okay. And I think we're ready to start. Instantly explodes. Oh, we have another, what is that? So many seconds until it starts. Like how clean this looks. So compact, so neat. Does it work? I had no idea. Oh, one way to find out, right? 3334. That one should be over here. 3334, yeah. How is our neutronium stores? We have 1,000,000. And how is our superconductor? Also 1,000,000. Okay. Oh, it even tells you information like that. Okay. I'm nervous. Guys, I'm nervous. I don't know if this is gonna work. It's okay, it's okay, it's okay, it's okay. We'll figure it out. We'll figure it out. I feel like I say that like very often. I guess you can say it's my catchphrase. No, I'm not ready for this. Here we go. 125 million. Bit 1 status is not okay. What does this even mean? Oh, the success chance is 100%, so it has fluid inserted this cycle is helium. So it worked. Yeah, it did work. Do have to make sure that this is here. So it did take a while because of this recipe progress flag. It takes like 8 to 10 seconds for it to actually output a signal. That's we're actually using that to our advantage. We also use that to our advantage in the temperature stuff. Somewhere. Yeah, right here. Recipe progress, and that is plugged into somewhere in our hot and spicy IC gate. But it looks like it did work. That's only one try though. See if it works again on the second run. That's where I'm most curious. If it works on another run. If I check up here, we should see only signal 1, right? Yeah, just the signal 1. I'm going to keep this at redstone dust because it's funny. But I think at this point you don't need to have it because having this signal over here fixed it. Current control signal binary is binary 1. Current output multiplier is 1. That might be something I want to focus on soon is upgrading it to have more superconductor or like a UHVT or something. Okay, here we go. Here we go. So it did work this cycle. And then this cycle is 100%. Oh, it didn't work. It broke already. Okay, okay. So it has to do with the supercoolant because it became 0. It became 0, right? So this is where we have to debug some more. So I turned it off for now, but so what happened was it was on 1. Right? And then it was doing this one. But why did it not keep? I might need to add a delay to Another thing is that it's getting this signal bleed from somewhere else. So it did get 20,000 supercoolant. So it got it twice, and it's not supposed to. But multiple things could have happened. I went way too high up. Either this one is running more than once, but no, it was working just fine when we were debugging it, so I don't think that's the case. Or it might be this signal over here. So when does it get this signal? Hang on, let me see over here. I think we just need a delay on this one because I'm assuming if this happens first. So maybe what happened was this one happened first, and then it turned off, and then it turned back on. All right, so I think we need to have delays for at least over here. So delays here maybe. Because yeah, I think what happened is if these if this turns off at the same time that this turns on, but if this turns on first, then yes, we're going to get an input. And it's not supposed to do that. So I need to make sure that these trigger after this one. So no delays for this one, but I should add delays for these signals. So what does that mean? More repeaters. And I luckily have space right here. It has to be before the AND gate, though. If I put it after, then that just defeats the purpose of the repeaters. I don't know how much ticks I should give it, so maybe we can wait a second. You know, it can be, it's fine. 3 ticks, sure. 3, 1, 2, 3, 1, 2, 3. How about like that? So, for example, if it were like this, no, first of all, it's like signal 1, and it was like this, right? So I think what happened was it switched to this, enabled it, and then it turned off this. But I can't mimic that fast enough, right? So if I add this repeater delay, that should prevent that from happening. At least I hope it will. One way to find out. Okay. I think all I have to do is replace I'm gassy with that. Okay, let's see if that worked. Okay. So it's good to debug like this. I know I can set this to like actually debug, but I'm not going to. This thing is spending 62 million, which is, I don't even know what machine's doing that. Oh, you know what? What I haven't really done is set up the filters. I don't know if I have a filter for you, the tier 6 water. So I have about a minute to do that. Let's go do that. So I have tier 4, tier 5. I don't have tier 6 or 7. So go ahead and set those up. It's right here. Ultraviolet. There. And de-ion, is it, what's it called? Degassed water? What? Decontaminant free water. Okay, there we go. There we go. Then we'll see if it actually did start. I think we have another couple seconds left. Yep. Take a drink. Make sure this works. Okay. Couple squats for good luck. Okay, that's good to see that it's not doing anything until a couple seconds, and there it is. 100%. And it's doing signal 1-1, which does correspond to neon and superconductor base. This is number 3, our best friend, the one that caused all of these issues in the first place. But what I want to see is what happens whenever it restarts the cycle. That's what I'm most curious about. I want to fix that. We got 2 minutes. Let me see if there's something I can do in the meantime. Not too sure. I think I need to understand how the space assembler works. Yeah, I wasn't really planning on doing much else after this. I just really want to make sure this works. And then we'll come back to it. But how much water are you producing, first of all? 57,000. I'm okay with that, honestly. But what do you call it? The crafting input buffer does need the space assembler module. So how does this work? I think I just need to give it stuff. Yeah, it looks like I just need to give it the controller and then input hatch and item input bus, right? And that should be pretty much it. So I did craft this off camera, and there it's ready. So I guess while we're waiting for this, actually it's almost done. We'll wait for this. It's just 10 seconds. Oh yeah, okay. So this is what I want to see. I want to see if it actually works correctly on retry. Okay, it didn't get any extra fluid. That's good. And then on 8 seconds, it should get the correct fluid. And there it is. 100% chance. Okay. That looks like it's working. Oh man. Yeah, I think that repeater trick did the work because it was switching those signals too fast, and I guess it got the input one first, which is not good. We want the input one last after this one switches. If I see more issues down the road, I probably am just going to add more delay to it, honestly. Okay, I think this was a pretty good experience. Next up is a machine controller, and I'm going to trust that it works. I know it's very bold of me to say that, but I am going to watch it for a little bit at least off camera. But I am going to connect this to a level emitter so that I can try to aim for 10 million of this stuff at least. I think I can do this, right? With redstone. Okay. Okay. And then I should be able to give you a signal. Just like that. And then I want you to work with degassed water. 10 million. Emit when levels are below limit. I think that works. Oh, you missed a cycle, right? Of course you did. Stop raining. You missed a cycle. Okay. But we do have... Actually, I think this is it. We can just make the crafting input buffer, right? Because we have the water. We have everything else for it. Oh, do it. We're going to end the episode with decontaminant-free water. Crafting input buffer. That's what I've been wanting this whole time, so let's do it. So, space assembler module. You can go somewhere. I think I could just put you right here. And then you need... It's Mark 1, right? Okay, you better just need Mark 1. I'm going to need a relay. A input hatch. Quadruple 1 is okay. And honestly, I think the first one is actually going to be put right here for the space assembler to make more of them. And then an input bus. Then an interface. Quadruple input hatch. I can put that there. That's actually going to be a little bit of a mess. I'll put this one right there, like that. And then input bus, dual interface, inventory relay, point into it. Thank you. And then your temporary, I just want you to craft like one of them. Then once I actually craft it, I can replace it. I just want you to move over there. I gotta do something about the optical cables. These are a little bit of a mess. A little bit of a mess. Yep. So if I give you the recipe for the crafting input buffer, there you go. You mean missing channel? Out of channel space? Oh, I totally am. Oops. Okay. Just for now, I just want to see this working. I'm going to hijack channels from another controller. Watch this, watch this. Wireless. And what better one to do than the one that we just set up earlier today? That would be you. Double check this is working now. Let's go back to this, make sure that this is working. 100% success chance. It's getting 110, which corresponds to neutronium and superconductor base. So that's working correctly as well. Okay, cool. And we'll come back in a couple seconds and check if it works correctly on retry. But this guy has the pattern. Can I craft the crafting input buffer now? No, you need quadruple input hatch UEV. Oh. Honestly, it's not that bad. I'm going to have to put this in the up tier for one. But it also means I have to upgrade the regular ass machine to UEV tier because I can't craft it. Here. How about now? That is a little pricey. Do it. Probably should have crafted it ahead of time. And also let me go to the up tier ass machine and set it to circuit 4. Circuit 4, yeah. There we go. I do have plenty of energy hatch, UEV energy hatches just hanging out here, I think. So I can totally upgrade it, precise assembler to that, but I'll do that probably on the next episode. Okay, how about how are you doing? You restarted? 100%. You have a binary control signal of 101, krypton, and neutronium. It's working. Sweet. I'm pretty glad it does, actually. I was a little nervous that it wasn't going to work. But we got it going. Okay, so this craft itself is actually going to be pretty expensive. So I think what I'm just going to end up doing, this is going to be off camera, of course. I'm going to watch it for a little bit, but I think we'll just go ahead and wrap up the episode here because I'm going to be honest, I'm a little burnt out with the with the deep dive into stuff like this. It was a lot of research, but I think we're done. And I'm going to go ahead and leave it running on at least up to 10 million. and then I'll come back, and I'll still be up for like another hour or two, just taking care of things. But I think what I'm gonna do is craft the first one, and then maybe just craft a whole bunch of them. Yeah, let's make a whole bunch. I think then like the next goal is upgrading our base to craft these even faster, because I'm gonna need a ton of these. And a big reason is we are moving to level maintaining, so having crafting input buffers is going to make things a lot less laggy, first of all, and faster, especially these 3 machines. So any of the universal automations, they're slow because every time Ender IO conduits is transferring items, that's a delay, and that really slows this down. But that item transfer delay is not present with crafting input buffers. At least that's how I understand them. So that alone is going to make a big difference. And then this just scales with any other machine that has a lot of things to deal with. It's going to be so good. So I'll try crafting a whole bunch of them, actually. We'll try 10. 10, maybe. And, well, I guess 11. It's a lot of crafting it has to deal with, though. I think we just ate all of my circuits, right? It is crafting like 1,000 or 6, I guess we can say 700 UV circuits. That's funny. Oh man, those are expensive. These are expensive. They made this cheaper, this version, right? Because before it was like you need a space time or something like that. So I'm glad that they made it cheaper, but it's still very expensive. How's this doing? I just need to make sure that this is working. 100% chance. And it has a signal of 1001, which means don't do anything. So that worked out. That's good. Awesome. Okay. I think we're good. I'm gonna leave that signal there. And so far, how much do we have? We're up to 301,000. That's a ton, actually. That's a lot. So I'm gonna leave it there. Level emitted up to 10 million. And then we're gonna craft a bunch of these crafting input buffers off camera. Got a lot to deal with, so we'll give it some time. And also, how's our Nequadria? Because I disabled that. And we're up to 41,000. That's really our main Nequadria sink, is that it kept crafting into the extremely unstable stuff, and we had no need to. There's no need for it, and that's where all our Nequadria was going. So we're gonna build that up now. Okay, and so at this point, this is a really big milestone. It may not feel like it, but this is a huge milestone, having these crafting input buffers, because it's going to change a lot with how we progress into the pack. And one thing I need to figure out, it's going to be a work in progress, but what I need to start thinking about is like expanding my area to account for like a lot more machines. Because right now, how this base is mostly set up is I just put machines as I need them. But that doesn't really give me a lot of room to expand. So for example, if I wanted to add a lot of electrolyzers, like there's not a lot of space for me to do that. I mean, there is, but if I add electrolyzers like all over here, that just gets in the way of other machines. So talked about it before, but I was thinking expanding the area past this way and having like designated machine spam. So I would have like an electrolyzer row or row of electrolyzers that just keep going all the way. Or maybe not all the way, but like big blocks of the stuff. Because it's time we need to ramp up production, I think. Because we have a resource generation, but we don't have a lot of production, I'm finding. So crafts like this are taking a while, and I want to speed up this. So I think our next major goal, our next major phase of the pack is improving the crafting of these the cribs. because it's going to make everything so much easier. But we're starting off with 11, which is great. Anyways, I'm going to check it one more time, and then if it works, I'm going to log off. Don't jinx it. Couple squats. Oh, yeah. 100% success chance. Oh, man. We figured it out. Nice, nice. Okay. I'm going to wrap it up here. Thanks for your time and support. It was a fun episode for me. It may have been a little boring for some of you or confusing, and I'm apologize for that. But for me, I had a lot of fun. And I hope you guys understand some of it too. But if you don't, just let me know. I'll try to explain what I can. Because I find that being able to explain something is also a huge part in learning. If you can explain it, then you can understand it. That's how I think of things, though. But anyways, for now, have a good night. Take care, and I'll see you guys tomorrow. Next stream will be tomorrow. See ya.